Hello, and thanks for coming. I'm looking forward to giving this talk. I'm Zhang. I'm a last year PhD student at Carnegie Mellon, and my research is on the societal impact of information technology. So I come from this in a couple directions, and today I'm going to be talking about my econometrics approach. So what we're going to do today is talk about some econometric style analysis to estimate how recent changes in urban transportation may have affected consumer behavior. So like I said, we're interested in studying how recent changes in urban transportation may have, because it's such an important piece of how we move and behave in cities, whether recent changes may have changed people's consumption behavior, or if it just simply replaces existing transportation. So specifically, I'm going to focus on Uber and Lyft, which, as many of you probably know, it's become very popular in the US, and we've seen high growth of use. Some work has looked at how Uber and Lyft has affected potential competitors. So how might taxis or other sources of transportation be affected with the entry and growth of Uber and Lyft? And like I said, since it's such an important piece, transportation being, our hypothesis is that if Uber and Lyft is shown to be very popular and we see that it's really being used heavily, we hypothesize that it's lowered the friction for local transportation. It's made it easier for some people to go places where they maybe had a more difficult time before. So in this work, we're trying to estimate, we're not necessarily there yet, but we're trying to use an econometrics approach to see if there has been a causal effect on some people where it's affected their frictions of local consumption. And this work is important not just to understand how a recent big change in our cities have affected us, but also how potential future changes might be affecting us. So as many of you know and probably believe, we're probably going to be soon to see self-driving cars in cities around the US at least, and the world. And so it's of use to urban planners, government officials, businesses to get a better sense for how self-driving cars might also affect our behaviors at the city level. And the reason for this is that I think both of these have a similar mechanism where self-driving cars might also further lower the frictions for individuals to consume locally. And so this is kind of going to be our motivating hypothesis that it's not just the presence of Uber and Lyft that affects our behavior, but mainly it's the usage. By using it, I demonstrate that I feel a lower friction, and on average, we're going to see that this potentially is increasing local economic activity. Sorry, I have a little cough. So the main research questions are, first, how did the availability of UberX and Lyft, when they entered several US cities over the last couple of years, how do they impact the adopters? So specifically, the language we're thinking is, what is the treatment effect of Uber and Lyft on the adopters? Not the average treatment effect on the population overall. This isn't really a policy study. This is more of how did the treated people who choose to adopt, how might they have been affected? So we're going to look at things like frequency of transactions, amounts spent, unique merchants they've visited, and distance traveled. And second, kind of furthermore, what are interesting heterogeneity or patterns in the impact of Uber and Lyft? So not just is there been an impact, but potentially what patterns and how can urban planners learn from how the effects might be different across different populations or areas. And our unique approach here overall is that we have a unique financial data set, and we're going to use this to both identify people's usage of Uber and Lyft and also their transaction patterns. So we have working with a financial institution, and from them we have a lot of consumers' financial transactions. We observe each individual for each day that they consume, and for each day we see where they spend money or what kind of categories, whether it's just some store or a restaurant or Uber and Lyft itself. And most importantly, we get their merchant names. So from this, we can identify, as you see near the bottom, whether a transaction was an Uber or Lyft transaction, whether it was a restaurant transaction or some other merchant transaction. And recently we've been able to take these names and geocode them a little bit, which is going to give us some preliminary results on distance traveled also. And the kind of motivation here is, do people go further if they have better access to transportation? And so the basic setup of the analysis here is we have data from 2012 to 2016 for 40,000 active and accounts that did not change cities. And the basic simplification idea here is we observe their behavior before Uber and Lyft is available, And then exogenous, we assume that it's an exogenous entry, at least to the individual level. This exogenous entry enables those who wanted Uber and Lyft to then start using it. And so you can see that these cars here are represented by transportation behavior, or specifically Uber and Lyft behavior. And the question is, do we see changes based on the amount of usage? So if someone's using Uber and Lyft more, do we see that being associated with a higher increase in restaurant behavior? And so in this paper, we're going to focus specifically on restaurant, food and drink categories, because that's where we believe the effect will be most strongest. So to visualize this again, this is someone's behavior before Uber and Lyft is available, and potentially we see that they take a certain number of trips in a month or in a quarter of a year, and we see an associated increase in their restaurant spending, and associated increased diversity in the neighborhoods that they go to. Alternatively, you can believe that some might argue that Uber and Lyft have not really changed our behavior locally. It just provides an alternative to taxis or buses. And so this, you might believe, is the alternative story. And so these are the kind of two stories we're trying to analyze. And we want to not just look at this from a kind of a correlation analysis, we want to kind of approach a causal estimate. And this is going to require a lot of robustness checks, but we can provide some preliminary evidence today. And lastly, we're going to see a lot of variation. So there's some Uber and Lyft entered over time, which is going to allow us to get identification over time trends. So we're not just a single time, we're going to be able to compare cities across cities that way. And this is going to contribute to the literature in a couple different areas of literature. First is the impact of the sharing economy. There's been some on the competitor sectors and some on complementary sectors. So how has Uber affected drunk driving? For example, has been a commonly cited piece of work. And it's also going to contribute to kind of the social impact of information technology. So our paper is a little more unique here because these other studies have studied the aggregate level. At the city-wide level, what changes have they observed? But we luckily have individual level data. We can track individuals over time and specifically look at their usage and see their usage of this technology moderates the effect. And importantly here, the reason I'm kind of calling this a quasi-experimental analysis is that we're using a couple forms of identification to not just look at patterns, but to identify potential experimental setup. So first is that Uber and Lyft have entered various cities across time, from 2013 to 2014, over several different time periods. So this is going to allow us to control for national trends. By looking at places without Uber and Lyft, we can get estimates for national trends to control for that. Furthermore, we have individual consumption patterns both before and after the adoption of Lyft, which is presumably exogenous to the individual level. And this is going to allow us to control for individual fixed effects. So allow us to see a consumer both before and after they have access to this technology. And then third, you might assume that Uber and Lyft's entry is not exogenous to the city level. There might be city-specific trends. Uber might enter cities where there's going to be booms in growth, and that timing might not be random. So for that, we're going to look at people who we don't observe as having used or Uber and Lyft. Perhaps they drive more, or they have alternate sources of transportation. And so this is going to help us control for local specific time trends. So these multiple forms of identification will help us be more confident in the estimates we're finding. And we're also going to look for using matching methods to reduce our control group to find a group that matches our adopters. Obviously, adopters are a bit self-selected, so we're going to use kind of propensity score matching methods and various robustness on that to find similar adopter group trends. So these are our various kind of setups for identification. And let me talk through an example. Like I said, on the green line, this is kind of the daily food and drink average transactions for adopters, and then red is for the non-adopters. So as I said, the adopter group is a bit different from the non-adopters. I mean, they may just be more active users of the credit card. So when we do some propensity score matching, we see that we have pretty good support, and we have a pretty good kind of overlap in terms of the estimated probabilities of adoption here. And this is just one method. We want to do a lot more robustness on this matching. But what we find is that there's a much better relationship for once we look at only the propensity score matched non-adopters. So this is our control and adopter group. What we see is we have a better parallel trend assumption, which makes us more comfortable in using the non-adopters as a local city-specific counterfactual. And loosely, this is a model-free evidence for we're going to run a regression model to estimate what we're seeing in this picture. So does the adopter group, when they use Uber, do we actually see this associated increase in usage that we see in this picture? And similarly, this is for one city, one metropolitan area, and this is for a different city, and with a different entry time. And this is a little more fuzzy, but it seems like there plausibly might be a potential increase in usage for the adopters here as well. So to talk through the main setup of our analysis, we're going to run, this is kind of our main regression we're going to focus on, our main econometric specification. We're going to run a log on the outcome of interest. This could be frequency, number of transactions in the time period, or amount spent in the time period. And we're going to log that because it's a very skewed number. And so this will allow us to estimate the elasticity of some of the right-hand side variables on the outcome variable. We're going to control for individual fixed effects, location fixed effects, and time fixed effects, all estimated using the identification I talked about earlier. And what we have here in the second line I want to point to is first we have an indicator for entry. Is there a post-entry effect on the adopters? So E stands for entry, and then E interact with I is the entry for adopters. Do adopters see a potential post-entry effect on their transaction consumption behavior? And then on the second part we have Q, which is going to be their usage. So this is actually what we think should be the most significant part, is not just is there a post-entry effect, but is there an effect associated with usage? We don't really expect there to be an effect besides post-entry, except with network effects. But we really do, I think, in our hypothesis, think that if you use Uber more, we should see that associated with a higher increase in your outcome. And importantly, though, what you might be concerned about here is that there's reverse causality. So in periods of high usage, if my usage is stochastic, I might be using, if I want to be going out and eating more, this may be just be happening to use Uber more. And so there's some reverse causality concerns here, which is something that we try to address, and using several forms of robustness. But most importantly here, we look at the X term, which is going to control for the monthly or quarterly total consumption. So we're thinking total consumption is a proxy for whether you're in a high period or low period. And furthermore, by aggregating at the monthly or quarterly level, we think this is going to get rid of some of that reverse causality concern. And so, okay, let's talk about some of the results. So first, in this first column, we have the regression analysis on our matched and adopter sample without including the usage term. So that's the first column. There, we don't actually see any significant effects. But once we include usage, we see that there's a strong relationship between each Uber and Lyft transaction and the adopter's increase in, this is number of transactions in that month. Or the percent, so one Uber transaction in this case is estimated to have a 2% increase in the adopter's, or associated increase, observed increase in the adopter's number of transactions. So but there's also a potential negative, you see this small negative effect on post-entry. So this suggests that if there is no usage, that the adopter is not actually, maybe consuming less than the control group in that case. But the more they use Uber, we actually do see an increased association. What I want to do is also, we look at their specific adoption dates. So this is a histogram of the specific adoption dates in our sample. This kind of ranges from 2014 loosely to 2016. And when we include the specific adoption date for each individual as well as the entry date, the results remain fairly similar in terms of the usage coefficient that we're looking at. Except we also see a negative coefficient for the post-adoption effect, suggesting that in periods where a consumer is not using any Uber or Lyft, that they may actually have lower usage or consumption than their control group. But then when they do use it a lot more, we're going to see the associated increase in usage, suggesting these off and on periods that we were thinking about. And lastly, we're going to look at, we're going to look at across a couple different outcomes. So we have amount spent per transaction, and number of unique merchants. So we actually have a stronger coefficient, a larger coefficient when we look at amount spent and amount spent per transaction. And thus we have a slight increase in the number of unique merchants visited as well. And so the number of unique merchants, we've actually tried to improve this. We've been recently geocoding our merchants, trying to identify exactly how far a consumer may have traveled for their consumption. And so I don't have the results up currently because of some server, like some privacy, because of our connection with the bank. But preliminarily, we're seeing also an increase in distance traveled as well. What I want to show here is an important falsification test. So what we see here is there seems to be this relationship between usage and your increase in consumption outcomes on this table. What we want to say here, this is the same exact table, but instead of looking at just food and drink transactions, which we have here, we're going to look at all your transactions minus the food and drink transactions. And what we see here is there's the same, an order of magnitude less, or in some cases even negative, if you look at amount spent per transaction or your number of unique merchants. There's actually a negative relationship there with Uber and Lyft usage. And this is good because it tells us, it both reinforces our robustness concern that it's not just this reverse causality concern, that it's not just if I'm in a high period of consumption, that Uber and Lyft just happens to be an indicator of that. That in some cases we actually see if you increase Uber and Lyft usage in that quarter or that month, there's actually a negative, slightly negative coefficient, significant coefficient on your amount spent per transaction, non-food and drink transactions. So this is still preliminary and we want to dig into it more. But this is asks the bigger question for not just how does your consumption change for food and drink, does it increase or not, but how does your overall portfolio of consumption change? Do you spend more locally and perhaps less online? So this is stuff we're still looking into, but I think it's promising results, and at least so far we haven't ruled anything out yet. And lastly, what's important, something I want to point out is that we see that there's this really diminishing return on Uber and Lyft usage. So for consumers who only use it a little bit in this time period, we see a much higher associated coefficient. While if you look at the bottom one, that's our top 25% of users, they have no relationship in their coefficient of usage and the outcome of interest, number of transactions, amount spent. And this again kind of makes us feel more comfortable with our potential confounding concern. So we see this kind of, as we would theorize, people who are more on the edge of maybe would use it occasionally, we see a much higher association with their increase in consumption. Whereas those who use it all the time, they might be the ones who are actually replacing their existing transportation with Uber. So this matches our proposed mechanism. And lastly, we see also temporal heterogeneity. There's a much stronger effect in terms of associated increase in consumption at the weekend days. And like I said, we have a little bit more on distance traveled as well. So I think in order to make this study more convincing and to get a better sense for are we actually getting a true result, we've been doing some additional robustness. We aggregate by different windows. When we look at the quarter, we think that the confounding reverse causality concern should be less there. So quarter, we see very similar results at the quarterly level. When we just look at the post period, not looking at usage, we get rid of usage. We see that consumers who use it a lot we see a similar kind of pattern to this, where we see that there's a bit of the increase and then decrease in the post-entry period when you interact that with the user subgroups. So the top 25% doesn't actually see a post-entry period increase in outcomes, increase in consumption behavior. Kind of that might be the group that might be just replacing their existing transportation. Whereas the people who use it a little bit or a medium amount, we actually do see significant increases in their post-period of Uber adoption, getting rid of the usage term. And lastly, if you're concerned about our matching, we also look at adopters only, and there we see also similar results, just looking at only those who have adopted. And lastly, I want to conclude by saying that we're still continuing to work on this. And so our first goal is to get a clean estimate and really do a lot of robustness there. But after that, we have a lot of interesting questions that we'd like to ask. So getting a little more, if you're an urban planner, thinking about which zip codes do you see larger effects? And maybe on the other side, which restaurants, potentially can we estimate restaurants, or neighborhoods of restaurants that have received a much larger increase in activity? due to those adopters? Are people traveling further than they might? How do suburban and urban consumers, how might they differ in their behaviors? And looking at places where had Uber entered, then left, and then entered again, we can kind of validate our proposed mechanism. Looking at competing transportation, looking at weather shocks, and doing some more semi-parametric and time series methods to make it a little more non-parametric are things that we're working on currently. And with that, thanks for listening, and look forward to questions.